Welcome to the Webrunner 2049. The internet is built on a wall that separates kind. Tell either side there is no wall, and about a war, or a slaughter. So what you see today didn't happen. I'm Babak. This is a joint work with my great colleagues Oleksii, Pierre, and my advisor Nick. And the topic of our work is evaluating third-party anti-bot services. Okay, so why are we talking about bots and bot detection, and why is it important? Well, it turns out that during 2019, more than 37% of the total internet traffic was produced by the bots. And at the same time, us, the security and privacy researchers, usually build bots and crawlers to collect different pieces of information from websites on the internet. So on one side, we have the good bots, either the search engine bots that index the websites to make it available for their clients, or the researchers who rely on the scripts to collect information from different websites on the internet. And on the other hand, we have the bad bots, the vulnerability scanners or the botnets that usually look for flaws and vulnerabilities to exploit the target systems. Now, in this ecosystem, some high-profile websites usually receive more targeted attacks. And this includes account fraud attacks, where the bots either try to brute force their way into the accounts by trying different passwords, or the account takeover attack, where the bots actually use a leaked set of credentials from one website on the other websites with the hope of breaking into the accounts of users who reuse their credentials. Some other websites receive content scraping attacks from the bots, and these bots usually scrape sensitive or valuable content from these websites. Could be the product price information, the inventory information, and sometimes they also mount denial of inventory attack, where the bot will go ahead and purchase all the stock of an item available on the target website, and as a result, the real users cannot go ahead and purchase that item anymore. Now, there are anti-bot services that protect the websites against these types of attacks. So in our study, we focus on three certain types of bot attacks. The account takeover, as I said, using a set of stolen credentials to log into a target account. Password brute force, where in our scenario, we try 1,000 incorrect credentials on a target website, and then try to log in to our own user account that we were brute forcing with the correct credentials to see if we were blocked or not. And for content scraping, we create bots that perform 1,000 content scraping attempts from different pages on the target websites. And now we want to know what would it take for these bots to be successful in their attacks, and are these protected websites actually safe against bots? So we collected a list of 15 popular anti-bot services. Some of them provide generic defense against all types of bot attacks, and some of them focus on account protection. So in the table on the right, you see the ones with bot attacks and account fraud. And for the services that you see a G in front of them, we could actually obtain a trial account or a paid account on them, set up our own protected website, and perform the attack. So that way we have access to the reporting panel, and we can see if the bots were successful or blocked. And we also analyze the fingerprinting module that most of these services use to identify the browsing environment and identify the bots and automated environments. So a typical structure of a website that is protected by one of these anti-bot services looks like this. So on the left, you have the client, could be a real user or a bot, and on the right, you have the web server. Now, the client wants to visit this web server, but the web server is protected by an anti-bot service. So what happens is that they give you an SDK where you integrate that with your server-side code, and they also give you a JavaScript, the fingerprinting module that you put on all of your pages on a website. Some anti-bot services also give you an option to get their firewall, either the hardware device or by setting your DNS settings, to route your traffic through their system. So now when the user comes to this website and loads the web page, the JavaScript module runs and sends a fingerprint, the browser fingerprint, to the anti-bot service. And at the same time, the SDK on the web server will collect different information from the server-side web environment. So this can be the event, the rate of requests, Was it a successful login attempt? Was the username available on the target website? And based on this information, the anti-bot service will generate a risk score and return it back to the web server to be acted upon. So when it comes to this risk score, we observe different types. So some of these services communicate the raw risk score. For example, the Cloudflare would report a risk score between 0 and 1 being definitely a bot, 0 being definitely a human. And they also provide guidelines on how to react to this risk score. So they tell you if the risk score is above 0.3, show a CAPTCHA. If it's above 0.8, block the user. And then it's up to the website administrator to fine-tune this number. Also, some of these services communicate the final verdict. So for example, the service named Castle, they do report the raw risk score in their admin panel, but what the SDK reports to the website is either allow, challenge, or block. And there also exist services which handle everything in the background. So as soon as you integrate the SDK with your website, they take control. If they decide the traffic is a bot, they'll redirect it to a CAPTCHA page or a blocking page. You don't have to do anything. And when they decide to block the bot, they also have different reactions. Some of them show a page, like the screenshot that you see on the right. They show you that we detected you as a bot, solved this CAPTCHA, and some of them block you by the IP address, so you can switch your IP through a proxy and keep doing the attack. But some of them block you by the fingerprint. So as long as you're using the same bot or the same browser, even if you change the IP address, they can still detect you and block you. And when it comes to account brute force attacks, some of these services, when you keep brute forcing an account, they keep increasing your risk score in the background. So even if you find the correct password after 800 attempts, they still will not let you log in. And sometimes when they detect you as a bot, they'll return an empty page as a result. So we looked at the fingerprinting module that is present in almost all of these services. They use JavaScript to collect different information, such as the screen properties. We observed that 8 services look for different fonts that are available on the target system. Also, 8 services performed Canvas and WebGL fingerprinting. Some of them looked for inconsistencies, and they did it using JavaScript. So, for example, they check if the navigator JavaScript object says that you're running Windows, but the user agent says you're running Linux. Another interesting thing is that 7 services checks for automation. These are any artifact that can tell that you're running an automated browsing environment, like a headless browser, specific JavaScript objects that are available when you're using Phantom.js or Selenium. 3 services try to get the real IP address of the users through WebRTC and Flash, and 5 services looked for the user actions. They either do this once or periodically. So they check if your mouse is being moved, if the keyboard is being worked with, to identify the automated environments. And they also use popular fingerprinting libraries like Fingerprint.js2, Plugin Detect, or EverCookies. So when it comes to our testing methodology, we perform static and dynamic analysis on this JavaScript fingerprinting module on all of these services. For the 4 services where we could obtain a paid or a trial account, we perform the gray box test where we have access to the administration panel. And for all of the services, we do the black box test where we take 10 websites randomly protected by each service and mount our attacks against them. So when it comes to our experiment, we have bots from different categories. We have basic bots like Python, very simple. Sometimes they don't even run JavaScript. We have automated browsers, which are real and full browsers, but they can still be detected because they're automated. We automate them using Selenium. We also have less popular fingerprints, and these are the fingerprints that have less history of malicious activity. So we expect that it is harder for services to block them. And we also launch our attacks from campus and cloud IP addresses to measure the effect of a trusted source IP, campus, and a well-known public data center, the cloud IPs, on the results. So from the basic bots, we use Python request library and Phantom.js. For automated browsers, we automate Selenium. We use Selenium to automate Firefox and Chrome. And for some of our tests, we block the JavaScript that is going to fingerprint the browser to see if that gives us a higher number of successful attempts. And we also emulate the mouse movements on the page for the services that actually look for these, the mouse movements and keystrokes to see if that gives us an edge. And from less popular fingerprints, we automate Chrome on Android using ADB, and we also automate Safari on Mac using AppleScript. So when it comes to the results, we actually had 6 services that defended against generic bot attacks. We had 10 services that defended against account attacks. And we want to answer these questions. Is the source IP address a big factor in the success of our attacks? Are certain types of bots more successful than others? And are these protected websites actually safe against bot attacks? So starting with content scraping results, we realize that the source IP address is not a big factor. The fact that you're scraping content from campus IP or a public cloud IP address doesn't really change the outcome of you being blocked or not. For different types of bots, we observe that nearly all of the services are able to block basic bots. When it comes to the browsers that are automated using Selenium, half of the services failed to block these bots, and only one service was able to block less popular fingerprints, and that service was blocking Selenium-based browsers after 20 attempts, but it took 300 to 600 requests for the same service to block our less popular fingerprint. We also identified that blocking the fingerprinting module and not sending back the fingerprint doesn't really help you to scrape more pages. But emulating simple mouse movements actually gives you an upper hand when you're scraping content against the services that look for this feature. So this was very basic mouse movements. This was in no way emulating a real user interacting with a website. We were just moving the mouse to different spots on the page 10 times. Okay, so moving on to the account attack. We observe that here, the source IP address actually becomes important. If you try to attack the accounts from a public cloud, 8 out of 10 services become more strict and block your bots earlier. When it comes to different tools, we observe that 80% of the services actually block basic bots, 60% of them block automated browsers, and only 30% were able to automate less popular fingerprints. Another interesting observation here is that, so these are the websites usually that had a bot problem, and they're paying a good amount of money to protect their website by integrating with the anti-bot services. But out of these websites, 63% did not enforce a local rate limiting to protect against brute force attacks. So when there was one of our bots that wasn't blocked by the anti-bot service and we could keep brute forcing the same account, there was no rate limiting on the username or on the IP address. So you could just keep attacking the accounts on the target website. Okay. Next, we have the password brute force results. And in this figure, we're comparing different types of bots. On the left, we observe that Phantom.js is a worst performing tool. And all the way to the right, we observe that Safari is a best performing tool. So the thickness or the width of the plot shows the number of websites that blocked us at that number of attempts. So when the big part of the plot is on the bottom, like Phantom.js, it shows that most of the websites were able to block Phantom.js in less than 200 attempts. But if you look at Safari, the top part of the plot is thicker. That means that more number of websites could not block Safari after 1,000 attempts. And the fact that the middle part of the plot is thin means that they either block you really early on or do not block you at all. And also by comparing the light shade of blue to the dark shade, the campus and cloud attacks, you could see that the campus attacks were slightly more successful. And this is more visible in Safari and Firefox and less visible for Phantom.js. So overall, the automated browsers and less popular fingerprints were more successful, and campus IP addresses were more successful than cloud IP addresses for password brute force attacks. Another interesting observation was that different websites that were protected by the same anti-bot service reacted different to the bot. So for example, one website protected by service A would block Selenium Chrome, but allow Firefox. Another website protected by the same service would block Firefox, but allow Chrome. And we can attribute that to certain cases. So one possibility is that the representative traffic for these websites was different. So if the services were performing behavior analysis, the machine learning model was different for one of these websites. It can also be that the customization of the rules on these websites makes for this change in the outcome. So some of these websites may have a higher false positive rate or be more sensitive, lower the threshold, and as a result, allow some of the bots to go through. It can also be the case that some of these websites either have a mobile application or perform automated tests, and these APIs could not run JavaScript or could be using Selenium themselves, and that could at the same time whitelist some of the bots. Okay, so now let's think, why is it a hard problem? So it looks like almost all of these services through browser fingerprinting collect enough information to be able to detect the bots. And we also know that the fingerprinting methods that we know of are working well in isolation. So if you have a method that is able to detect Selenium, that works really well. But when you integrate this and deploy this on a customer website, this suddenly becomes a hard problem. One reason could be that false positives are really costly, because if you block the real customers, that's a lost business and the loss of revenue. So protected websites really don't want to block real customers. And then there is no clear cut here. We don't really know, is it the customer's fault that these websites are not protected, or is it the fault of anti-bot service? Because the anti-bot service will come and claim that, yes, we have the protection, we have the ability to detect these bots, but in this deployment, the customer decided to change something, and now suddenly the bot attacks are going through. It is also important to think of the effect of these anti-bot services on the researcher. So it is very common that researchers build automated tools and crawlers to gather information from the popular websites. It is not only the malicious actors that create the bots. So we should be mindful that when we're performing this type of study, these services could be blocking our bots, and the result of our study could be skewed and could be portraying a different image than what the actual users would see through those websites. So to conclude, we would like to remind the researchers to be mindful of these services and know that they could be affecting their results. We would like to suggest that you use more sophisticated crawlers like Selenium or less popular fingerprints compared to Phantom.js or Python scripts. And also, it was interesting that using the right tool, up to 80% of websites were susceptible to content scraping attacks. And the worst performing tool, being Phantom.js, could still successfully perform account takeover on 60% of the target websites. And again, using the right tool, you could achieve a success rate of 82% in account takeover. And the majority of protected websites do not have a local rate limiting to protect them against password brute force attacks when the anti-bot system fails to block the bot. And we also observe the disconnect between what the anti-bot service thinks and what the customer sees, the protected website. So we would like to suggest that anti-bot companies build automated test pipelines to check the deployment of their customers. So with that, I would like to conclude my talk. I hope you learned something, and you can contact me if you have questions either over email or on Twitter. Thank you.